Okay, the second video that we're starting with for section 1.8 deals with composite functions. We just did combinations of functions. Composite functions are a little bit different because they are basically functions embedded within one another. And you probably recall seeing them as that and sometimes that. Okay, either way, what they're read as is f of g of x. Okay, this one right here is not called fog, it's f of g of x. Okay, calculating them is just a matter of plugging the g of x function in for every x that exists in the f of x function. And again, this is something that we've done before. So let's try those same two functions that we used in the last video. F of x equals 3x plus 4, g of x equals x squared minus 2. If I'm interested in finding f of g of x, I take g of x and I plug it in for every x in f. And then I just use algebra to simplify it as best I can. So when I do that, 3 times x squared is 3x squared minus 6 plus 4, and finally my answer is 3x squared minus 2. Alright, let's say that I want to find g of f. Okay, now I'm taking my f function and plugging it in wherever there's an x in my g function. So I have 3x plus 4 squared minus 2. The $1,000,000 mistake, guys, is thinking that 3x plus 4 squared is only equal to 9x squared plus 16. That is the $1,000,000 mistake, because it's made a zillion times so that if I had 1 penny, 1 cent for every time that it occurred, I would have a fat stack of cash. Should make me happy. Okay, so anyways, don't make that mistake. You need to set up 2 sets of parentheses. 3x plus 4 times 3x plus 4. Oop. Okay, good enough. And when you do that, I better still write it down. 3x plus 4, 3x plus 4. Okay, FOIL it out. 9x squared plus 12x plus 12x plus 16. Okay, that's where that all came from. And simplify it as best you can. So the final answer for g of f of x is 9x squared plus 24x plus 20. So you should notice right away that, oh, I did it again. You should notice right away that f of g does not necessarily equal g of f. Okay, and you can also embed a function within itself. Say that I wanted to do f of f. Well, then I take my function f and I plug it in wherever there's an x in f. So I have 3 times 3x minus 4 plus 4 as a perfectly reasonable operation. So we simplify it down. Our final answer is 9x plus 16. Next, the domains. Now these require a little bit of analytical thinking, whether you can say analytical thinking or not. Because this is why. You need to consider the domains of both functions. Any restrictions in the embedded function, any restrictions on the embedded function may not actually appear in the resulting function. So if you just wait until the end of a composite function to figure out what the domain is, you're going to miss some restrictions that would have gone into the embedded function. A real simple example is taking f of g when f of x equals x squared and g of x equals x. Well, we know that when we take f of g, we end up with just x. If your composite equation is just x, you would think that the domain was all reals. But in fact it's not. And it's not because we have a restriction right there. Even though it gets squared, originally x has to be greater than or equal to 0 in order for this to work. That does not lose itself just because our final answer happens to be x. We need to keep that in mind. Okay, so keep in mind the embedded function and make sure that you don't lose sight of what the domain of it was just by looking at your final answer. Okay, here's another example. Suppose we want f of g in this situation. Well, f of g is just going to end up being 1 over the square root of x minus 1. Okay, now we have to consider all things in this. Original function was, or our original two functions, this one, g of x, x has to be greater than or equal to 0. This one, x cannot equal 1. Well, it happens to be present in our final answer too. We have to have a real number here, so x has to be greater than 0. And furthermore, the square root of x minus 1 cannot equal 0. So that means if you set this up, you end up with square root of x equals 1. Actually, does not equal 1, which means x cannot equal 1 squared, which is 1. So, and this is an example where the restrictions that we had in the beginning are still there in the end. So our domain is all reals greater than or equal to 0, but x cannot equal 1. So keep those things in mind when it's time for you to figure out the domain of a composite function. And that is the end of this one.